Okay, let's continue with that last lecture. We talk about the properties of DFTs, and also we talk about the circular convolution. Okay, let's continue with the properties of the discrete Fourier transform. So today what we discuss about that multiplication of two sequence. So last class what we talk about? We talk about if the two sequence, if the x1 n is one sequence and x2 n is another sequence, if endpoint DFT of x1 is x1 k and x2 is x2 k, then the multiplication of x1 k and x2 k, if I take the inverse DFT, then we have proved that it is nothing but a circular convolution of inverse DFT is nothing but a circular convolution of x1 n and x2 n, or I can say if a x1 n and x2 n are circular convolution in time domain, then frequency domain is nothing but a simple multiplication x1 k multiplied by x2 k. Now, if I see the reverse side, let us say I said x1 n and x2 n are simply multiply in time domain. So, in time domain x1 n and x2 n are simply multiply. Now, in DFT domain, so if I said x1 n, DFT of x1 n is x1 k and DFT of x2 n is x2 k, then I can say if I simply multiply these two things x1 n and x2 n, and then if I take the DFT, then it is nothing but a circular convolution of x1 k and x2 k. So, have you understand what I said? So, I said that if I take the multiplication and frequency domain, we have proved that time domain it is nothing but a circular convolution of point n. Similarly, if I simply take the time domain multiplication and in frequency domain it is nothing but a circular convolution. So, this proof can be just change the role of x1 k and x2 k, you can do that proof. So, your home exercise is do that proof. Okay. Simply interchange the role of time and frequency in the expression for circular convolution of two sequence, you get that. So, what is that? What concept I said? That if a two sequence x1 k and x2 k, if I take the endpoint DFT, it is capital X1 k and capital X2 k, then x1 k and x2 k if I multiply and take the inverse DFT, it is nothing but a circular convolution of time domain signal x1 n circularly convolved with x2 n. Similarly, if I say that multiplication in time domain x1 n is multiplied with x2 n, and if I take the DFT, it is nothing but a circular convolution in frequency domain x1 k circularly convolved with x2 k. Okay? Now, I come to the time reversal. So, let us say x1 n is my signal and the capital X k is my the frequency domain signal or k domain signal. If I take the DFT endpoint DFT, I get x k. Now, if I shift it time reversal, so I just reverse the time. So, x of n was there. So, reverse of time means x of minus n. So, you know that sequence is periodic at n. So, I can say x of minus n capital N, which is nothing but a x of n minus n. If I take the DFT of x of n minus n, it becomes x of n minus k or x of minus k. So, how do you prove it? Very simple. You put instead of x n, you put x of n minus n. Okay? Now I said n equal to 0 to n minus 1 x of n minus m. So I took this is m. So m equal to 0 to n minus 1. Instead of n, I put n minus m. So I said m is equal to n minus m. So I can say the n is equal to n minus m. So I put n minus m instead of n. Okay. Now here also, if n tends to 0, that means m tends to n tends to capital N, m tends to 0. So that's why I said n to 0 or 0 to n, doesn't matter. Okay. So I put n minus m. Have you understand or not? I said I take the signal x of n minus m. Now n minus m is equal to m, small m is equal to capital N minus small n. So n small n equal to n minus m. I put the value of small n here, and instead of n minus m, I put the value of m. When n equal to 0, n equal to 0 means m equal to capital N, and when n equal to small n capital N, then m equal to 0. So it will be n equal to 0 means m equal to n, n equal to n means m equal to 0. So I can say 0 to m minus n minus 1, same thing, only I change it. Okay. So I write down this. Now if you see that e to the power j 2 pi k n minus m. So e to the power j 2 pi k plus, this is plus k m by n into e to the power minus j 2 pi k n by n. So n by n cancel. So if we see that 2 pi k is an integer. So e to the power minus j 2 pi is nothing but a 1. So this factor will be 1, because this is nothing but e to the power minus j 2 pi k n by n into e to the power plus j m 2 pi by n. Okay. So that it will be there. So if you see it is positive, so I can make it minus and minus of n minus k. I take it negative, so I know x of n minus k is equal to x of minus k. K is negative here, so I said x of n minus k. Is it clear? So time reversal. Similarly, if I go to the circular time shift, another property, circular time shift, xn is my signal, DFT is capital Xk. Now if I say circular time shift, because I know x of n, if the n point DFT is calculated, then the period is n, and x of n is repeated circularly. So x of n is repeated circularly with n. So I have to shift circular time shift. So I have to shift within. So I can say, as you saw, when you do the circular time shift, what do you know? That if I shift this wise, this is positive index. If I shift this wise, this is negative index. So since if I shift this wise, so that means x of n minus L within the period of n, which is nothing but a capital X of k, which is the Fourier transform of x of n multiplied by e to the power minus j 2 pi k L by n, as if the time shift of L unit, xn time shift of L unit, as if the frequency response is shifted by e to the power 2 pi k L by n. So x of k multiplied by e to the power minus j 2 pi k L by n. Proof is this one. So DFT of x of n minus L capital N. So which is the circular, now circular shift is L point circular shift. So, I put x of n minus L, x of n minus L is the signal. So, I can say this is nothing but a n equal to 0 to L minus 1, this one, this sum n equal to 0 to n minus 1. So, I can divide it in two parts, n equal to 0 to L minus 1, n equal to L to n minus 1. So, because n varies from 0 to n minus 1, the L will be within that. So, I said let us n varies from 0 to L minus 1 and then varies from L to n minus 1. So, I write down sum in two sum form. Now, you know that if it is circular shift, so x of n minus L plus n is nothing but this one circularly shift, because complete the circle it is again start shifting. So, if this is the circular shift, then I can say that instead of writing n minus L mod of capital N, let us write this one, n equal to 0 to L minus 1. So, what will come? So, I can say this one is nothing but a m. So, n capital N minus L plus n is equal to m. So, when n equal to 0, m is equal to n minus L, capital N minus L, and when m equal to L minus 1. So, when m equal to 0, when n equal to 0, the capital M. So, what I said? So, I take the first sum part, and what I am saying, first sum part I am taken. Now, I know that x of n minus L mod n, it can be written as x of n minus L plus n, or n minus, or I can say n minus L, the L minus n is okay. So, it is circularly shifted, after n point it will be again shifted. So, now I said n minus L plus n is equal to m. Now, I said when n is equal to 0, then m is equal to n minus L. When n is equal to n is equal to L minus 1, then m is equal to n minus L plus L minus 1. So, it is nothing but a capital N minus 1. So, I replace m is equal to n minus L to n minus 1, x of m, this is nothing but a m, e to the power j 2 pi. Now, n is equal to m plus L minus n. Small n is equal to m plus L minus capital N. So, if I put it here instead of n, so I can get e to the power minus j 2 pi k m plus L minus n divided by n, which is nothing but a e to the power minus j 2 pi k m plus L divided by n into minus minus a plus j 2 pi k n by n, which is nothing but a 1. So, it is nothing but a this one. Okay. The other sum, the other part, this part, n equal to L to n minus 1, n equal to n minus L. So, n is, now I can shift it n minus L is equal to m. So, when n is equal to L, m is equal to 0. When n is equal to n minus 1, so it is nothing but a, So, m is equal to then n equal to n minus 1 minus L is equal to m. So, it is nothing but a n minus 1 minus L, m equal to 0. So, this term will be this one, this term will be this one, but n minus L is equal to m. Now, n minus L is equal to m. So, n is equal to m plus L. So, I put m plus L here. Okay. So, m plus L divided by n. Okay. So, here I get m plus L divided by n up to n minus 1. So, I can get DFT of x of n minus L is equal to m equal to 0 to n minus 1. So, here I get the sum. Here I get the sum m equal to n minus L to n minus 1. And here I got the sum m equal to 0 to n minus 1 minus L, n minus 1 minus L, and here I get n minus L to n minus 1. So, if I together, it is nothing but a m equal to 0 to n minus 1 x of m e to the power j 2 pi k m plus L by n. So, DFT of x of n minus L is equal to sum m equal to 0 to n minus 1 x of m e to the power minus j 2 pi k L m plus L divided by n. This is one part, this is second part. So, this part related to this part and this part is related to this part. So, if I add them, m equal to 0 to n minus 1. So, this is nothing but I can say m equal to 0 to n minus 1 x of m into e to the power minus j 2 pi k m by n into e to the power minus j 2 pi k L by n. So, this part is nothing but a x of k and this part is nothing but a e to the power minus j 2 pi k L by n. Okay. So, that is called circular time shift. So, a L time shift means e to the power minus j 2 pi k L by n will be added. Similarly, I can talk about the circular frequency shift. So, instead of shifting in here, I am shifted in here. That will be same as x of n e to the power j 2 pi n L by n. Circular frequency shift, because k also varies from n, after n it is circularly repeated. Now, when I use the circular shift? Circular frequency, where I require a frequency shift. So, suppose I have designed an low pass filter, this is FC, cutoff frequency, or I can say omega c, not discrete domain omega c. Now, if I want to shift it in here, so I require a circular shift, I require a frequency shift. So, instead of let us center frequency here, which is nothing but a omega c by 2, the center frequency, this part is omega c. So, if I center frequency want to shift it to here, let us say f0 omega 0 plus omega c divided by 2. So, I require a omega 0 amount of frequency shift. So, if I multiply, let the frequency time impulse response of this filter is h of n. If I multiply by e to the power minus j 2 pi n L by n. So, how do I define how much omega 0, how much shift is required, what is the value of L? So, I know the frequency resolution of the transform. So, if the Fs is equal to 8 kilohertz and n is equal to 1000, then I know resolution is 8 hertz. So, 1 k change means 8 hertz change. So, let us say I require I have to shift it by 1 kilohertz. I have to shift it by 1 kilohertz. So individual k means 8 hertz. So I know 1 kilohertz divided by 8, that much of k shift is required. So that much of value L should be 1 kilohertz divided by the frequency resolution. That much of L, if I multiply with impulse response of the filter, then I get the shifted version. Frequency response will be the shifted version. So details we discuss when I design the filter. So this is called circular. Why it is called circular? Because after k equal to n, it will be repeat itself. So that is the circular shift. Okay. Next is complex conjugate property. If x of n DFT is x of k, then the x of, let us say x of n, what is the complex conjugate of x of n? X of star of n, which is nothing but a x star of minus k, which is nothing but a x star of n minus k. So I know that x star of n minus k. So if x of n has a frequency response is x capital X k, then I know that x star n has a frequency response which is nothing but a x star of n minus k. So complex conjugate. And other property also I know that x of n minus k is nothing but a x star k. That property also I know. X of n minus k is equal to x star k. Okay. Now FD, let us say circular correlation, another property. Circular for a complex value sequence xn and hn. Xn is the signal, hn is the impulse response, and let the frequency response is xk and hk. Then the circular correlation is the correlation circularly shifted. So correlation and convolution, circular convolution, circular correlation, which is equal to nothing but a x of k multiplied by h of k, h of star. You know that if this is the sequence, then you know x of n, if the circularly convolved with h of n, which is nothing but a x of k multiplied by h of k. Now instead of circularly convolved, if I calculate circularly correlation, instead of circular convolution, so that means folding is not happened. So without folding, I get just multiplication of the frequency response of xk and hk. Now in case of correlation, it will be complex conjugate of hk. Here, since in correlation hk is not folded, that is why I get the complex conjugate. So you know that x of minus k, or I can say x of minus k is equal to, we have proved that x of minus k minus n is equal to x of n minus n, which is nothing but a x star, what I said, which is nothing but a x star k, complex conjugate of k. So you know that this is folding is not happening, that is why it is star. Okay. So that is circular correlation. Then perversal relation, that if you see that if x of n is my signal, then you know what is the energy of the signal, summation over the time, square and sum over the time. So if it is an infinite duration sequence, then it is n equal to minus m into infinity x of n whole square is the energy of the signal. If it is finite duration signal, then energy is equal to n equal to 0 to n minus 1 x of n mod x of n whole square. That is the energy of the signal. So, whether I calculate the energy of the signal in time domain, and I can also calculate the same energy of the signal in frequency domain. So, x of n is frequency domain representation is x of k. Now, I know the whole energy is transferring here. So, the if I calculate the energy in here, x of n whole square must be equal to the energy in frequency domain, which is nothing but a 1 by n, k equal to 0 to n minus 1 x of k whole square. You may say that, sir, we have an x of n dft is x of k, then where I get the 1 by n? You know that dft is nothing but a n multiplication. So, its gain is increased by n times. That is why when you take the reverse dft, we decrease it 1 by n. Since it is energy, so energy will be increased by n times, that is why 1 by n has to be multiplied. Okay. So, that is called, you can say, perversal relations. Okay. So, energy, I can compute the energy in time domain, I can also compute the energy in frequency domain. In tutorial, I will show you how this can be done. Okay. So, this is the properties of, I can say, the properties of discrete Fourier transform. So, this is the properties of discrete Fourier transform. Okay. So, all the property somehow we will be used during solving the problem, or when you go for the frequency domain analysis, all kinds of things. So, we may use one of these property. So, you have to remember those properties of discrete Fourier transform. Okay. Thank you.